Hello students, in this video we are going to study about the next topic of the testing of hypothesis, that is a chi-square test. This is also one of the most important type of the test which we are using in testing of hypothesis. So before we are going to start with the problems based on this particular part, I just brief you about the chi-square test as well as the chi-square distribution. So firstly, what is the chi-square variate? Firstly, it is pronounced as a chi. Chi is a chi-square variate. So the square of the standard normal variate is called a chi-square variate. We already know that z, which follow normal distribution with mean 0 and variance 1, it is called a standard normal variate. The square of the standard normal variate, which is equal to, like if I say that x follow normal distribution with mean, mu and variance sigma square, right? Then z, which is a standard normal variate, which is x minus mu upon sigma, it will follow normal distribution with mean 0 and variance 1. Then the square of the standard normal variate, that is x minus mu upon sigma whole square, then this will follow chi-square distribution or chi-square variate with 1 degree of freedom. Okay, so if x follow normal distribution, then z is a standard normal variate, then the square of the standard normal variate is a chi-square variate with 1 degree of freedom. Okay, and if we consider an independent normal variate, say x1 x2 so on xn, with the n independent normal variate with mean, that is xi follow normal distribution with mean mu I and variance sigma I square, then their sum, then if we take the sum of I varies from 1 to n, xi minus mu I upon sigma I square, then this will follow chi-square, it will follow chi-square variate or chi-square distribution with n degree of freedom, because we are going to take the sum of n square of standard normal variate, right? So it will follow chi-square variate with n degree of freedom. So like sometime the MCQ type question could be framed that if z follow normal distribution standard normal variate, then what about the z square? So z square will follow chi-square variate with 1 degree of freedom if we are considering only one random variable. If we are considering n independent standard normal variate, then the square of these zi, if we take the sum of all these, then it will follow chi-square variate with n degree of freedom. Okay, so before we proceed, first let me give you some idea about the properties of the chi-square distribution. The first one is the probability density function of the chi-square variate. Okay, although it is not of the interest of anyone, because we are not going to study about the chi-square distribution, we are interested to know about the testing of hypothesis only, but it is just for the sake that the probability density function of chi-square distribution is given by 1 upon 2 raised to the power n by 2 gamma n by 2 e raised to the power minus x by 2 x raised to the power n by 2 minus 1, and here the value of x is greater than or equal to 0. And if you just look at here, we know that in case of gamma distribution, that if random variable x follow gamma distribution with the parameter n, then its probability density function is given by 1 upon gamma n e raised to the power minus x x raised to the power n minus 1, right? This is the probability density function of gamma function, right? So in this case, if I replace x with x by 2, then we find that if x follow chi-square variate with n degree of freedom, then x by 2, that will follow chi-square gamma distribution with parameter n by 2 only. Okay, so you can see here, if I simply replace n with n by 2, then automatically, then because we have transformed our function from x to x by 2, then we need its derivative. Okay, so derivative of x by 2 is 1 by 2, so we get one additional 1 by 2 here. So on the basis of that, we can get this probability density function. So basically chi-square variate, if x follow chi-square variate with any degree of freedom, then we can say that x by 2 it will follow gamma distribution with parameter n by 2, right? That means with the help of that particular concept we can easily derive the probability density function also. Some of the important properties of chi-square distribution is, if there are two independent chi-square variate with n1 and n2 degree of freedom, then the sum of the two chi-square variate will also follow chi-square variate, where we are going to add their degree of freedom. Okay, like sometime the MCQ type question could be framed that if x follow chi-square distribution with degree of freedom n1 and y follow chi-square distribution with degree of freedom n2, and x and y are independent, then what about x plus y? Then x plus y will also follow chi-square distribution with degree of freedom n1 plus n2. Apart from this, there are some more properties that the ratio of the two chi-square variate will follow beta 2 distribution, right? It is a beta 2 variate with parameter n1 by 2 and n2 by 2. So basically beta 2 distribution with parameter m and n, right? It can be defined as, that means its probability density function f of x is given by 1 upon beta mn x raised to the power m minus 1 upon 1 plus x raised to the power m plus n, where the value of x varies from 0 to infinity. Okay, so it means that the ratio of the two chi-square variate with follow beta 2 distribution with parameter n1 by 2 and n2 by 2, means I am going to replace here m with n1 by 2 and n with n2 by 2, right? And this is the probability density function for the same, for the beta 2 variate. And here beta mn is means this is, there is a relation between beta function and gamma function, that beta mn is gamma m gamma n upon gamma m plus n. And if we take the sum of the chi-square variate and then we take the ratio, then the ratio of chi-square variate divided upon the sum of the two chi-square variate, it will follow beta 1. So what about beta 1? Its probability density function is given by 1 upon beta mn x raised to the power m minus 1 1 minus x raised to the power n minus 1, where the value of x varies from 0 to 1, where m and n they are non-negative integers. Okay, so here we have written the probability density function of beta 1 and beta 2 distribution also. Okay, so here the most important property in case of chi-square distribution which is required is that the sum of the two chi-square variate is also chi-square variate with the degree of freedom sum of the degree of freedom of their independent chi-square variate, right? Okay, now come to the next is the some of the important application of the chi-square distribution is, chi-square distribution is basically used to test the hypothetical value of the population variance, means either the sample has been drawn from the population whose variance is sigma square. Okay, and second one is the most important property, that is our concern is the goodness of fit. It is also used to test the independent of attributes. It is also used to test the homogeneity of independent estimate of population variance, various probability obtained from independent experiment to give single test of significance, and to test the homogeneity of independent estimate of population correlation coefficient. But in this particular video our main focus is on this topic of goodness of fit only, right? So we are going to focus on the topic goodness of fit. So let us come to that particular part. So chi-square test for the goodness of fit. So what does that mean? So basically in this case we are going to consider chi-square test as a non-parametric test, because in this case it will not involve any parameter. It is called the non-parametric test. Okay, because in this case we are concerned only about the observed frequency and the expected frequency, right? So what we want to know that that if we are conducting an experiment and we have observed some frequency, and on the basis of some criteria we are going to calculate the expected frequency also. So in this case, our hypothesis is there is no significant difference between the observed frequency and the expected frequency, right? And how we are going to calculate the chi-square statistics, right? The criteria of testing of hypothesis is same what we are doing earlier. That is, we are going to follow some step. The first step is the setup the null and the alternate hypothesis, null and the alternative hypothesis. This is the first step. Second one is we need to choose the level of significance, appropriate level of significance. Like I told you, if it is not given, then we preferably choose alpha equal to 5%. Otherwise, if it is given, on the basis of that we can choose 1% or 10% also, depend upon the type of the problem only. The third one is we need to calculate the test statistic. The test statistic in this case is chi-square, which is equal to summation I varies from 1 to n observed frequency minus expected frequency, it's a square divided by the expected frequency. So it will follow chi-square distribution with n minus 1 degree of freedom. In this case, we are going to consider the degree of freedom as n minus 1, although we are taking sum of n terms only, right? So why we are considering n minus 1 degree of freedom? Because in this case we have a constraint that the sum of the observed frequency, it should be equal to the sum of the expected frequency. So this is the necessary condition. So that's the reason we lose 1 degree of freedom. Every time when we add some constraint, we'll lose 1 degree of freedom, right? So in this case, with the help of this, we are going to calculate the test statistics, and the last one is the conclusion. So conclusion means that on the basis of the given level of significance and the degree of freedom, we are going to calculate the we are going to compare the calculated value of chi-square with the chi-square at the given level of significance and the degree of freedom. We are going to compare these two value, and on the basis of the either we are going to accept or we are going to reject the null hypothesis, or reject the null hypothesis, that is H0. So this is the procedure we are going to follow here in case of chi-square test, right? So one more important thing, what is the condition for the validity of the chi-square test? Under what condition we can use chi-square test? The first one is, the condition is the sample observation should be independent. Second is the constraint in the cell frequency, if any, should be linear. That means this is the necessary condition, that the sum of the observed frequency and the expected frequency, this is the necessary condition. So this is because we lose 1 degree of freedom. And the third one is, again this is the important one, the total frequency should be reasonably large, that is greater than 50. Okay, what does it mean? It means that when we take the sum of the observed frequency or sum of the expected frequency, its value should be greater than or equal to 50. Okay, and what about n? N represent the number of observation, right? For example, we are given the observed frequency as say 15, 35, 28, 15. And what is n? N is the number of observation, 1, 2, 3, 4. We are given 4 observation, right? But this is the frequency, means the sum of this frequency should be greater than 50. This is the condition, right? Okay, and the value of n, because when we are going to calculate the degree of freedom is how many this kind of observations are given here. Okay, and the next condition is no theoretical cell frequency should be less than 5. So like here we are given the frequencies 15, 35, 28, 15. So if any one of the frequencies is less than, for example this is the observed frequency and we are given the expected frequency as say this is 13, this is 29, this is 32, and this is 3. So if any cell frequency is less than 5, then we are going to apply the concept of pooling. That means we are going to pool it either with the preceding or the succeeding frequency, so that the pooled frequency is more than 5. Means either we merge this frequency with the previous one so that this pooled frequency should be greater than 5. Okay, and after that what we need to do, finally we need to adjust the degree of freedom, right? Because earlier we are having 4 observation, but now when we are applying pooling, so it means that this side also we need to apply pooling, so it is 28 plus 15 become 43. So it means that now instead of 4 we left with a 3 observation only, so we already lose 1 degree of freedom because of this pooling. Okay, and on the basis of that only we are going to calculate the value of chi-square at the given level of significance and n minus 1 degree of freedom. Okay, so uh, one more important point is that because chi-square is nothing but the square of the standard normal variate. Chi-square is nothing but the square of the standard normal variate, and we know that normal distribution is a symmetric distribution. Its value varies from minus infinity to infinity. But when we are going to scale this value, if I say that the value of z varies from minus infinity to infinity, and when we scale this particular number, it means that this its square value must lies between 0 to infinity only. So the chi-square distribution is a positively skewed distribution. Its distribution scheme is like this. For example, if I show you the chi-square table, and then this is the shape of the chi-square distribution. It is already given in this particular part. So in this case, in general we are considering the distribution as a right hand distribution only, means we are going to apply right tail test only. Okay, so because in this case this is not symmetric, although we can apply the two tail test. In this case, two tail test means that if we have to calculate, if we have to apply the two tail test, in this case we are going to consider alpha by 2 from this side and alpha by 2 from this side, but in that case we need to calculate both the values separately from this particular table, because in this case this curve is not symmetric curve, right? Okay, so to understand this criteria, let us consider one problem on the basis of the chi-square distribution. Let us come to this problem. Okay, so the question is the demand for a particular spare part in a factory was found to vary from day to day. In a sample study, the following information was obtained. So we are given this distribution data that the demand of the spare part uh, on the basis of the days only, right? Like on Monday the demand of this spare part is 1124, on Tuesday it is 1125, on Wednesday it is 1110, and so on, right? So the question is, test the hypothesis that the number of parts demands does not depend on the day of the week. Okay, so what we want to test, that we want to, this basically this is the observed frequency, this is the observed frequency which is given here, and what we want to test, that we want to test that the demand of the spare part doesn't depend upon the day of the week. Okay, so the first step is we need to decide what is the null hypothesis. So because in this case it will not involve any kind of parameter here, so we need to write the null hypothesis in the form of a statement only. So what is the statement? The statement will be, null hypothesis is the demand of the spare part does not depend on the day of the week, right? Okay, why we have chosen this? Because by default we know that null hypothesis means no difference. Null hypothesis means no difference or no change. So generally we are assuming that there will be no change in the value. It means that the demand of the spare part will remain same throughout the week. And what about the alternative? The alternative hypothesis will be the demand depend upon the day of the week. The demand depend on the day of the week. The demand of the spare part depend on the day of the week. On the day of the week. right? Okay, so now the next step is we need to firstly consider the level of significance. So if you can see here, it is given the value of chi-square at 5, 6 and 7 degree of freedom and 5% level of significance. It means that what is the level of significance? So level of significance alpha is already given here 5%. And how many observations are given here? This is a week. 1, 2, 3, 4, 5, 6. Except Sunday, all the weekdays are considered. So it means that the value of n is 6. If the value of n is 6, then the degree of freedom in this case is n minus 1. N minus 1 means 6 minus 1. So 6 minus 1 means 5. So what is the value of chi-square at 5 degree of freedom and 0.05, 5% level of significance and 5 degree of freedom? At 5 degree of freedom, its value is already given as 11.07. So its value is 11.07. So we want to check that either the value, calculated value of test statistics, is greater than or smaller than this one. Okay, so the next step is we need to apply test statistic. So what is the formula of test statistic? Chi-square is equal to summation observed frequency minus expected frequency upon its square divided by the expected frequency. This is the formula. So what is our assumption in this case? Our assumption is that the demand of the spare part does not depend on the day of the week. It means that I am assuming that the demand of the spare part will remain constant throughout the week. So the first step is I'm going to write, like, I have considered this data. This is the observed frequency 1124, 1125, 1110, 1120, 1126 and 1115. Okay, so this is the observed frequency. If we take the sum up, then the sum comes out to be 6720, right? And because the total number of observations are 6, so if I divide it with 6, then its value comes out to be 1120, right? So because what is my expected frequency? My expected frequency is the demand of the spare part is same throughout the week. So it means that I'm assuming that its demand will remain same throughout the week. So I'm assuming the expected frequency is 1120. So when we sum up, again its value comes out to be 6720. So this is the sum of observed frequency and this is the sum of expected frequency. So you can see here this particular condition is satisfied, right? So now we are going to apply the chi-square test. So what we have to do, we need to calculate observed minus expected square. So firstly I calculate the difference of these two, then we take its square and then divide it by expected frequency. Okay, so I have calculated this particular data using Excel. If you want, I'll demonstrate here that how can we calculate this particular one through Excel. So our observed frequency, let it be denoted by OI. So observed frequency is let me show you here, it is 1124, 1124 and then next is 1125. On Wednesday it is 1110 and on Thursday it is 1120. On Friday its value is 1126 and on Saturday it is 1115. And if we take the sum, so we simply take the sum of all these observations, so its value comes out to be 6720, right? And what will be the expected frequency? So for expected frequency I simply divide this number by 6, so that will gives us the expected frequency is 1120. So what is our expected frequency? It is 1120, 1120, 1120, because my assumption is that the demand of the spare part will remain same throughout the week, right? So now if we apply the sum formula here, so I simply drag this column, then we can get the sum formula here, its value also comes out to be 6720. Okay, so it means that the condition of sum is satisfied, right? So let us consider this particular table here. So this is the table available with us, right? Now what is the next step? The next step is, now we have to calculate the test statistics. So for test statistics, firstly we need to calculate observed frequency minus expected frequency, right? So we find out the difference of these two, observed frequency minus expected frequency. So if I find out difference, it is 4. So next is 5, and I simply drag this one. So this is the sum, and if we drag, so its value comes out to be 0 only, right? And next is, I need to calculate observed frequency minus expected frequency, its square. So for square, I'm going to take the square of all these terms. So 4 square is 16, 5 square is 25, 10 square is 100, 6 square is 36, 5 square is 25, and if we calculate their sum, this is the sum. But I don't need this thing. I need the value of observed frequency minus expected frequency, its square divided by the expected frequency. This is the formula of test statistics. Means I am going to divide this value with the expected frequency only, right? And now we are going to calculate this term, and then we sum up all these terms. So its sum comes out to be 0.180357. Okay, so this is the value of the chi-square characteristics. So you can see here, if I show you here, so the calculated value of observed minus expected square divided by expected frequency, its value comes out to be 0.180357. so its value comes out to be 0.180357. okay, and because this is the calculated value, and if I compare it with the tabulated value, okay, like I told you, chi-square is a basically right-handed distribution only. So in this case we have applied right tail test only. So if the critical value is 11.07, it means that the region right to this particular point is the region of rejection. So the region of rejection is if the value of chi-square, calculated value of chi-square, is greater than this one. Because the value is smaller than this one, it means that the value falls in the acceptance region. It means that the value falls in the acceptance region. So because chi-square calculated is 0.1803, which is smaller than the chi-square at 5% level of significance and 5 degree of freedom, so it means that what do we conclude from here? So we can conclude that its value means that chi-square calculated falls in the region of acceptance, so it means that null hypothesis accepted. So it means that null hypothesis accepted. So null hypothesis expected. So what can we conclude? It means that the demand, or so the conclusion is, the demand of the spare part does not depend upon the day of the week. Okay, so basically in the problem we are given the observed frequency. So with the help of the given criteria, we need to calculate the expected frequency, we need to set up null and alternate hypothesis, and generally we are considering the right tail test only, because the chi-square distribution is a right hand is a positively skewed distribution. Okay, till it is not given in the question, we are always considering it as a right tail test. But if it is given in the question that sometime the question is that we need to calculate the confidence interval, so in that case we need to calculate the left limit as well as the right limit, okay, with the help of the table itself. Okay, and then we can calculate the confidence limit, otherwise we apply only right tail test. Okay, let us try another problem. So another question is, a survey of 320 families with 5 children each revealed with the following distribution. So we are given a table where a family having 5 children, some of them are boys and some of them are girls. Like there is a family which having 5 boys. How many families are there? 14 such families are there, because they have considered about 320 families. Means if I sum this entire row, then its sum comes out to be 320. Okay, so the question is this result consistent with the hypothesis that girls and boys are equally probable? Okay, so we want to check that either boys and girls are equally probable or not. So what is the null hypothesis? So in this case the null hypothesis is the boys and girls are equally probable. So what does it mean? It means that the probability that the child is a boy is equal to 1 by 2. This is equal to the probability that the child is a girl. Its probability is also 1 by 2, right? And what about the alternate hypothesis? The boys and girls are not equally probable. Boys and girls are not equally probable. Okay, so because in this case the question is not given, so we are going to consider the level of significance as 5%. So we are going to consider the level of significance, that is alpha, as a 5%. Okay, so we need to calculate the value of chi-square at 5% level of significance. And how many terms are given here? There are 6 cases we are given, when 5 boys up to 0 boy and 0 girl to 5 girls. So it means that total number of observations are 6. 1 2 3 4 5 6. So again the degree of freedom will be n minus 1, means 6 minus 1 is 5. So it means, like in the last question, its value will remain same, 11.07, right? Otherwise we have a chi-square table also. We can refer chi-square table at 5% level of significance. 5% level of significance means from the right hand side we need to leave 5%. It means that when the probability is 0.95, okay, or so 0.05 this side at 5 degree of freedom. This side we are given the degree of freedom, so 5 degree of freedom and 0.05, so its value is 11.07. okay, so we can refer, but generally you are given the value in the examination. Whenever the question is asked in the examination, they will give you value in this way, like x is chi-square is greater than chi-square at for 5 degree of freedom, right? So for 5 degree of freedom, its value is greater than 11.07 is equal to 0.05. So the value of chi-square for 5 degree of freedom is greater than this particular one, is only 5% chances are there, right? Because the 95% of the area falls in the left hand side. Okay, so it means that this is 11.07. so this side we have only 5% area we have. Okay, this is the meaning we are given this table, right? Now the next step is we need to calculate the statistics. So what is the test statistic? The test statistic is chi-square is equal to summation I varies from 1 to n observed frequency minus expected frequency square upon expected frequency. Okay, but in this particular case we are given the observed frequency, so we are given the observed frequency as 14, 56, 110, 88, 40 and 12. So we can consider one of the parameters. Suppose I can consider y only. So here we are given the variable as x. X represent how many boys we have. So this is corresponding to 5 boys, 4 boys, 3 boys, 2 boys, 1 and 0 boy. So how we are going to calculate the expected frequency? We are going to consider the expected frequency using the rule that boys and girls are equally probable, right? So what is the probability that in a family we have a 5 boys? So in this case, when the number of trials are 5 and we want to find out probability of x equal to x and the probability of success is known, so then we can apply binomial distribution, right? So when we are repeating the experiment finite number of times and the probability of success remain constant, then we apply binomial distribution. So what is the formula? NCx p raised to power x q raised to the power n minus x. So because p is 1 by 2, so q is also 1 by 2. So the formula is NCx 1 by 2 raised to the power x into 1 by 2 raised to the power n minus x. So x and x get cancel out, so NCx 1 by 2 raised to the power n. This is the formula, right? And because we need to calculate the frequency, so total number of families are 320, so its formula will be n into probability x equal to x. Okay, so what is the formula here? So its formula is, first case, 320 into 5c5 1 by 2 raised to the power 5. Then 320 into 5c4 1 by 2 raised to the power 4. 320 into 5c3 1 by 2 raised to the power 5. This will remain n only, right? So 320 5c2 1 by 2 raised to the power 5. 320 5c1 1 by 2 raised to the power 5. 320 5c0 1 by 2 raised to the power 5. So 1 by 2 raised to power 5 is basically 1 by 2 raised to power 5 is 1 by 32 and it is 320. So it means that we left with the 10 only. This is 10, 10, 10, this is 10, this is again 10, so this is again 10, right? So 10 into 1 is 10, so 5c4 is 5 only, so it is 50. 5c3 is same as 5c2 and 5c2 is 5 into 4 upon 2, its value is 10. So 10 into 10 is 100 and 5c2 again it is 100, 5c1 is 50 and this is 10. Okay, so what is the formula of calculating the factorial? I think you are aware about the binomial coefficient. NCR is equal to n factorial r factorial into n minus r factorial, right? So what is the formula of 5c2? It means 5 factorial 2 factorial into 5 minus 2 is 3 factorial. So I can consider 5 into 4 into 3 factorial upon 2 into 3 factorial. 3 factorial get cancel out, right? So what it means, if we simply consider the smaller term, 2 factorial means we are going to consider 2 term in the numerator, 2 consecutive terms starting from 5 and 4, and then we can calculate this. Okay, so what do we get here? Observed frequency is given here as 14, 56, 14, 56, 110. Then next is 88, 40 and 12. 88, 40 and 12. Now we need to calculate the expected frequency, which we have calculated as 10, 50, 100, 100, 50 and 10. Now the next formula is observed minus expected frequency and its square. The difference of these two is 4. 4 square is 16, 6 square is 36, 10 square is 100, minus 12 square is 144, 10 square is 100, 2 square is 4. And now we need to calculate observed minus expected frequency square divided by expected frequency. Divided by 10, 1.6, divided by 50, 7.2, divided by 100, it is 1, sorry, it is 0.7, it is 0.72, right, 1, and this is 1.44, and this is 0.5, and this is 0.4. Alright, so if we calculate 1, 1, 2, 1, 3 point, this is 40, 50, 1.00 and 1.60, right? 5, 4, 9, 4, 13 plus 7, 20, 26, and this is 4, 2, 6. So its value comes out to be 5.66. So what is the calculated value of chi-square? This is summation observed minus expected square divided by expected frequency. So its value comes out to be 5.66. But we have we already know that from the chi-square table its value is 11.07. But chi-square at 5% level of significance and 5 degree of freedom, its value is 11.07. So it means that the calculated value falls in the region of acceptance. Okay, so it means null hypothesis accepted. So null hypothesis accepted, it means that the boys and girls are equally probable. Basically you will find out the difference here, although this value is not exactly same, so it means that there is no significant difference. Okay, so we can say that there are not enough evidence which will prove that the boys and girls are not equally probable. So that's the reason we are concluding here that boys and girls are equally probable. So it means that whatever the difference is visible here, this is not a significant difference. This is only due to the fluctuation of sampling, right? So it means that there are not enough evidence which will prove here that the boys and girls are not equally probable, right? Again, if we want to cross check our calculation part, then we can use Excel also, right? For example, if I consider here the observed frequency is 14, 56, 110, 88, 40 and 12, and the expected frequency, it is 10, then 50, then 100, then again 100, then 50, and then 10. Okay, because these are binomial coefficient, right? So because these are the binomial coefficients, so it means that so we can easily calculate their value here. Observed frequency minus expected frequency, it's the square divided by expected frequency, right? So we can directly use this formula as, firstly we find out difference, this minus this, bracket close, its square, and divided by the expected frequency. So if we simply drag this formula, and the rest is the sum formula, sum we are going to calculate from here to here, so its value comes out to be 7, 10 square 100 okay, 100 divided by 50. Okay, so basically we need to consider here is 2. So that's the reason I told you it will be better that we can use the calculation part. It is not 0.50, it is 2, because 100 divided by 50, its value is 2. 4 divided by 10, its value, so its value is a 2 3 4 5, so it is 5.66 plus 2 is 7.66, right? Still the value is smaller than the tabulated value, so hence null hypothesis accepted. So what do we conclude from here? That the boys and girls are equally probable. Okay, now let us come to the next problem. So chi-square test is also used to apply as a goodness of fit. Like in this particular problem, we are going to, like in the last problem, we have applied we have used binomial distribution to calculate the expected frequency, right? So we can also say that that either the binomial distribution is a good fit for that particular data or not, right? So in this particular case, we are given that the first proof of 392 pages of book of 1200 pages were read, and the distribution of the printing mistakes were found to as follow. So we are given the observed frequency, that in how many pages we have a 0 mistake, how many pages we have a 1 mistake, how many pages we have a 2 mistake, up to 6 mistakes as here, and the total is 392. The question is fit a Poisson distribution and test the goodness of it. So we are going to calculate the expected frequency using Poisson distribution, and we want to check that either the Poisson distribution is a good fit for this particular data or not, right? So but for the Poisson distribution, we know that firstly, what is the Poisson distribution? Poisson distribution, the probability x equal to x, it can be calculated as e raised to the power minus mu raised to the power x upon x factorial. So here mu represent the average value, mu is the average value, right? So but if we look at this particular data, we are not given the mean of the Poisson distribution, so it means that we need to calculate the mean from the given data only, and we are given the data in the form of a frequency distribution, right? So firstly, let us consider this data. X is given here with 0 1 2 3 4 5 6, and its frequency is given here as 275 72 30 7 5 2 and 1, right? So what is the mean? So we know that mean we are going to consider here as a sample mean, which is summation fi xi upon summation fi, because we are given as frequency distribution, right? So we need to take the product xi into fi. So this is xi, this is fi. So this is 0 72, this is 60 21, this is 20, this is 10 and 6. So we sum up, so 16 36 57 60 117 119 plus 70 189, and the total sum of the frequency is, it is already given as 392. So the mean value comes out to be 189 upon 392. So we are going to consider it as a mu. We are going to consider it as a mu only, right? So with the help of this mu, we need to calculate the probability. So what is the probability of getting 0 mistake? It is e raised to the power minus mu raised to the power 0.0 factorial, that is e raised to the power minus mu. So what is the probability of getting 1 mistake? It is e raised to the power minus mu raised to the power 1 upon 1 factorial, that is e raised to the power minus mu into mu. So similarly for 2 mistake, e raised to the power minus mu square upon 2 factorial, that is e raised to the power minus mu upon 2. For 3 mistake, e raised to the power minus mu raised to the power 3 upon 3 factorial. So this is e raised to the power minus mu cube. This is mu square upon 2, this is 6. And similarly for x equal to 4, e raised to power minus mu raised to the power 4 upon 4 factorial is 24. And for 5, e raised to power minus mu raised to the power 5 upon 120. And for x equal to 6, e raised to power minus mu raised to power 6 upon 6 factorial means 720. Okay, so with the help of this we need to calculate the expected frequency. So what does it mean? Expected frequency is the frequency means the total number of page into probability x equal to x. Okay, so firstly we need to calculate the value of e raised to power mu, means mu is 189 by 392. We need to calculate this value, and to calculate this one we can refer calculator, or we can perform this calculation on Excel also, right? Let us consider this Excel. Let us consider a new file here. So I'm considering the observed frequency first. Observed frequency is given in the data as this is 275 and 72, then 30, then 7, then 5, then 2, then 1. And now we need to calculate the expected frequency, right? For expected frequency, firstly we need to calculate the value of mu. So what is the value of mu? Let me calculate here, because what I need observe minus expected frequency, it's square, right? Okay, but firstly we need to calculate the expected frequency first. Let us firstly calculate the value of mean. What is mean? This is equal to 189 by 392. And next step is we need to calculate the value of exponential of e power minus mu, right? Minus mean. Its value is exponential of minus of this number. Its value comes out to be 0.62854, right? Even you can use the calculator also. With calculator also you can calculate this value. So what we need to do, firstly we need to calculate the value of a mean, that is 189 divided by 392, and then we need to take the exponential of this particular one. So exponential okay, e power bracket minus of, okay, or we are not considering minus, 189 divided by 392. Okay, there is some mistake here. Let me set exponential. Okay, this is something different. E raised to the power bracket of 189 divided by 392. And then we take its reciprocal. Its value is 0.6174. But here we are getting some different value. Let me see. Okay, let us see. We multiplied with a negative sign. And we calculate its e power mean. as equal to exponential of that particular value. Still it comes out to be 0.628584 e raised to the power okay wait 189 divided by 392, so it is 0.48, but it is showing different value. Let me check. 189, right? 189 by 392. And now we multiplied with a negative sign. Right, now the value is correct. And if we take the exponential, now you can see the value is same. And we take reciprocal, it is 0.6174, right? Okay, so what I need to do to calculate the first term, we need to multiply e raised to the power mu with n, that is 392. So I'm considering here this is equal to 392 multiplied by this term. So that will gives us the first expected frequency. For the second frequency, what I need to do, I need to multiply by e raised to power mu with mu, that is e raised to the power mu multiply by, what is the mu we need to consider here? This is a, okay, wait, we need to consider this is not the mean value. The mean value is a positive one. Mean is equal to minus of this value, right? Okay, so this is equal to e raised to the power minus mu multiply mean. Multiply by 392. Right? E raised to power minus mu into 392, right? Because we need to multiply it with a frequency also. So what is the expected frequency? This is for the first one, that is E naught is 392 into probability x equal to 0. So probability x equal to 0 is e raised to the power minus mu. What is E1? It is 392 into probability x equal to 1. So this is 392 into e raised to power minus mu into mu. So this part you have already calculated, right? So what you need to do, you need to simply multiply it with the mean. So instead of calculating this whole term, what can I do? I simply multiply the previous term with, what can I do? I simply multiply the previous term with the value of mean. So it must gives us the same answer, right? So to calculate the next term, what I need to do, I need to multiply the previous term with mu. Now to calculate E2, what is E2? 392 into probability x equal to 2, means I need to multiply it with e raised to power minus mu into mu square by 2. So mu square by 2 means I multiply into mu and divided by 2, right? So this part we have already calculated in the previous term. This is nothing but E1, and we need to multiply it with mean divided by 2. Similarly, what about E3? This is E2 multiplied by mu divided by 3, because 2 we have already done. So how do we get mu cube? Multiply by mu and divide it by 3. So this will gives us this value. If I multiply it with mu divided by 4, this will gives us the next term. If I multiply it with a mu and divide it by 5, it will gives us the next term, right? So how do we calculate the next term? So for next term I am going to multiply previous term with mean and divided by 2. Now multiply the previous term with mean and divided by 3. Multiply the previous term with mean and divided by 4. Multiply previous term with mean divided by 5. Multiply previous term with mean divided by 6. So now if you write the sum, so what is the formula of sum? Simply sum up, control shift down, and if I drag this one, so approximately its value is 392 only, right? So we can round up one of the number so that its value will be same only, okay, because we have considered value up to 4 decimal places. That's the reason its value is approximately 392. Okay, so I can consider one of the number as a round up value only, so that its value should be equal to exactly 392, right? So what can we do? Like it is a 987, so I can consider 99, right? So what can I do? I simply copy this value, control C, and paste it as a value, control value, right? And I am considering it as 0.99. That's it. Now if we drag this value, okay, so we can consider it as a round up to 4 decimal places. Round up to 4 decimal places. Okay, otherwise close that. Okay, we have already calculated this value, so just leave this particular part. Okay, so this is the observed frequency and this is the expected frequency. But now there is one important point here. The important part here is that you will find out here there are certain frequencies whose cell frequency is less than 5, because if you remember that when we have discussed the important that is the condition under which we can apply the chi-square test, the condition is given here that none of the cell frequency should be less than 5, right? So if any cell frequency is less than 5, in that case we need to pool the frequency from the with the preceding or the succeeding one, so that the cell frequency should be greater than or equal to 5. So in this case what can we do? So in this case, if you just look at here, if I pool these two frequencies, then still the value is less than 5. If I pool these three frequencies, still the value is less than 5. So it means that we need to pool all these four frequency so that its value will be greater than or equal to 5, right? So what can we do? I'm going to copy this data, Control Shift down, Control C, let me paste it here, Control V, and I'm also going to copy this data, first 3, and now the next one is the sum of this is D6 to D9, D6 to D9. So because we have used the pen, so that's why it is not working here. Okay, now its value is more than 5, but because we have pooled these four values, so we need to pool these values also. So this can be written as sum of okay. So now I'm going to remove this frequency. So it means that instead of the 7 term, now we left with only 4 terms. So this is our now observed frequency and this is our expected frequency, right? And now we are going to apply the chi-square test here. So what is our test statistics? Observed frequency minus expected frequency, it's the square divided by the expected frequency. So what we are going to do here, observed frequency minus expected frequency, it's square divided by the expected frequency. And if we drag this value here, and now we calculate the sum, so this is equal to sum of these terms. So you can see here its value comes out to be 40.7741, which is a very big value, right? And so what is the calculated value of chi-square here? So the calculated value in this particular question, its calculated value of chi-square comes out to be summation I varies from 1 to n, observed minus expected square upon expected, its value comes out to be 40.77. And how many degree of freedom we left with? Now you can see here we actually left with only 4 observation, 1 2 3 4. These are the 4 observation we have. So what will be the degree of freedom? It is equal to n minus 1, so it is 4 minus 1 is 3. But there is one more thing. The another thing is, because in this case while applying the Poisson distribution, we need to calculate the mean, and to calculate the mean again we have used the given sampling data only. So when we use the sampling data to calculate the population parameter, again we lose 1 degree of freedom. So actually we left with only 2 degree of freedom. Okay, so how many degree of freedom now we lose? Because in this case we have merged these 4, so total number of observations are 7. So we lose, because we have merged these 3 term with this one, so we lose 3 degree of freedom. 1 degree of freedom, this is because of pooling. 1 degree of freedom because of the linear constraint, that is observed frequency is equal to expected frequency. This is the linear constraint, and further we lose 1 degree of freedom because we have calculated one parameter from the sampling observation. So now total we left with only 2 degree of freedom. So if I am going to calculate the value of chi-square at 5% level of significance and 2 degree of freedom, so what is the value of chi-square for 2 degree of freedom and at 5% level of significance? It means its value is 5.991. So its value is 5.991. So you can see here clearly this value is 40.77. so it means that this is the critical value 5.991, and this is the rejection region, and because 40.77 falls in the rejection region only, so it means that null hypothesis rejected. So what will be the null hypothesis in this case? So in this case, okay, we haven't write the null hypothesis. So null hypothesis will be that the Poisson distribution is a good fit for this data. The Poisson distribution is a good fit for this data. Good fit for this data. So what is the alternative? It is not. Okay. And level of significance alpha we have chosen here 5%, and we have calculated that chi-square at 5% level of significance and 2 degree of freedom, its value is 5.991, and the test statistic, that is chi-square, is equal to summation observed minus expected frequency square upon expected frequency. Its value comes out to be 40.77, right? So which is far greater than the chi-square at 5% level of significance and at 2 degree of freedom. So because chi-square calculated falls in a region of rejection, so hence null hypothesis rejected. So null hypothesis rejected. So what can we conclude from here? That Poisson distribution is not good fit for this data, not good fit for the given data, hence the result, right? So here these are the different types of the problem we have considered here for the chi-square distribution. That sometime you are directly given here the procedure, that in that case when the condition is that the data is uniformly distributed, then we simply calculate the sum of the observed frequency and we divide it with the number of terms. We can calculate the expected frequency and hence we can calculate the chi-square. But sometime we are given some criteria, like in this case it is given that boys and girls are equally probable. So in this case we need to calculate the probability. So what is the probability of getting the 1 boy, 2 boy or 5 boy or 0 boy, and we multiply it with the frequency. So with this criteria we can calculate the expected frequency. And the third case we have considered that if we want to check the goodness of fit of a data, that either any distribution is good fit for the given data or not. Okay, and here also we have considered the case when any cell frequency is less than 5, then how can we apply the case of pooling. So in this case, because the cell frequency is less than 5, so we have pooled these 4 cell frequencies. So when we pool this, then automatically we lose the degree of freedom. So because we have pooled 3 cell frequency, so we have lose 3 degree of freedom, and hence after doing the after adjusting the degree of freedom, we need to check the value from the chi-square table, and we compare the critical value with the tabulated value, and on the basis of that only we can decide that either we are going to accept or reject the null hypothesis. So I hope you will get an idea that how can we use the chi-square distribution. In most of the cases the long question was framed from this particular topic, so you will get an idea that how can we solve this. But of course calculator is very much required to perform such kind of calculation here. Okay, so here we have used calculator as well as the Excel also, but in the examination you have to make use of calculator only. So try to practice this problem. If you still find out any doubt or any query, you can ask me or post your query in the comment section. I'll try to provide you the solution for the same. Thank you and have a nice day.